Let's talk a little bit about cloud application delivery models. We're familiar with some of these, and a lot of this is still held true as much as there's nuances within each, but you've got this concept of infrastructure as a service. This is giving you really the raw compute, and this could be a physical machine, this could be typically a virtual machine, but it's where I'm really managing from the operating system up, where the service provider is managing things below that. They're managing the hardware. They're setting up the data center and dealing with cooling and power and some of those logistics that you don't have to deal with in this sort of cloud model. It's about giving me raw compute on demand, typically something of the size that meets my application workload need, but I take responsibility from the OS up. I need to patch. I need to set up the right networking topology. I've got to make sure that I've connected the various servers in my infrastructure in some sort of load balanced way. So I take a lot more ownership. I have a lot more control, but I also take a lot more ownership of having to set that up. Platform as a service is a bit overloaded. You've got kind of code-oriented platform as a services like Cloud Foundry, like OpenShift, like Azure websites, things where I'm meant to build and deploy applications versus a sort of constrained paths where it's force.com, or some of these where I'm assembling an application using kind of point-and-click methodology. It's very, very abstract sandbox. I don't really deploy code. And so paths can kind of run this spectrum of things from Google App Engine and code to force.com and point and click and everything in between. But the whole point is I'm trying to move up a layer from infrastructure. I don't care about the infrastructure. I don't care about setting up load balancing and networks. I simply want to have an application fabric to deploy applications to and manage them that way. Software as a service is about taking packaged software, delivered software, and sending it and making it available over the internet, so that I'm consuming this software as a service, meaning it's subscription-based, it's pay-as-you-go, it's something that typically has a cloud-like back end to it, so it can be delivered in a very scalable way. So software as a service, something clearly like Office 365 or Dynamics CRM Online, Force.com or Salesforce.com, all of these sort of applications delivered as a service to me. This kind of runs a bit of the gamut of cloud application delivery. You hear about database as a service, desktop as a service, identity as a service, a lot of things that still fit within some of these categories, but these are the major ways you segment cloud delivery. So why does platform as a service matter? I'll cover a few things. If you treat this as the middleware for the cloud era, which some have claimed, and I don't think it's too far from the truth, it's the idea of what is the right sort of application level tier that I want to deploy my applications to in this sort of elastic, fast, subscription-based cloud model. PaaS is great because it's application-centric. The infrastructure is invisible. You don't get to see, heck, even the file system, really. You don't see the infrastructure underneath it. You're not configuring a load balancer. You're not worried about how am I connecting the nodes that make up my application. It's application-centric from scaling perspective. How do I scale my app? How do I scale it ideally horizontally and add more instances? I'm not thinking about all the other things I have to deal with, about, hey, I have to update some router so it knows about these new nodes, or I've got to do this or that. I don't have to worry about that. It's app-centric. Get my app out there, scale my app, make it configurable, and the platform layer is handling things like failure recovery, handling things like listening on new nodes coming online and having the right sort of gossip protocol so things are communicated underneath the covers. It's about a faster time to market. It's about, can I provision quickly? When I'm getting PaaS containers and deploying apps in seconds versus standing up a physical machine and installing an OS and getting my app bits on there and getting things deployed, I'm really shrinking the amount of time it takes to get my application out there, make it very developer-centric so I can push my application quickly, possibly even to production, rapid prototyping, and I've got this host ready for me. Instead of having to go commission a server or find space on an existing web app server somewhere, I've got this container fabric ready to go that I can have this high density environment where I can put a bunch of apps in this environment, not just this one app per web server traditional model where I'm not getting the right utilization. I'm getting a better density, I'm getting a ready available host, and I can get that quick provisioning that makes it a lot easier to meet the needs that we're seeing more and more of getting apps to market. It's DevOps friendly, and the concept of developers are going to have this sort of fabric they can push to very quickly without having to know much about operations. In a private PaaS scenario, operations can really focus on delivering the right underlying infrastructure underneath the covers, maintaining that infrastructure in all the environments, where developers are really maintaining apps in all environments. I can check in my manifests. I can treat my infrastructure as code to some extent in a PaaS environment. And so it's very friendly to this sort of model of quick collaboration, separation of concerns, and being able to ship quickly while still maintaining some great diligence on the infrastructure side. One of the most underrated but great parts of PaaS is that sort of different runtimes part, where it's polyglot or multi-language friendly, where not every shop is a .NET shop or a Java shop or a Ruby shop. Instead, you typically do have different components in different languages that take advantage of the benefits of each. So when you can have all of those pushed to the same application environment, instead of having to commission standalone environments for each sort of app framework, I can push them all to the same place. That's fantastic for trying out new technology, for having college interns in the summer who all know Ruby and have no familiarity with Java. Hey, I can put them in the same environment. Or again, when I've got application components that are built and scaled independently, all running in the same place. The key, though, is the same policies. I can have the same usage governance. I have the same credential model. I've got the same sort of logging techniques, all within the same fabric. So I get the benefits of each individual framework, but they're encapsulated in a sort of governance model that makes it much easier to manage this at scale. We're going to go ahead and do our very first deployment. We're going to take an app and we're going to push it. Very, very simple. I don't want to make this overcomplicated, but we're going to really quickly install Node.js. We're going to install the Cloud Foundry command line interface. We'll sign up for a free Pivotal.io account where I can do Cloud Foundry development, and I can push the application. It should only take a few minutes, but you're going to get a sense of what it really takes to get up and running. I'm going to do this on a cloud server I've stood up so I can make mistakes and have fun and tear it down. But you can do all of this on your own desktop, or you can do this on a server elsewhere. Let's jump in. All right, let's jump in on the first demo here. Now, you'll see, hopefully you pulled down the zip file that came with the course files for this course, and inside of that are the different modules you need for the course, so you can go ahead and unzip that into a place that's convenient for you. I'll drop mine onto the C drive. Okay, so I've got all I need here. The Hello World one is in Mod 1. We'll have to install a couple of things first so we can deploy that application to Pivotal in the Cloud Foundry environment. First things first, let's go ahead and install Node.js. Now I'm doing this on Windows. All of these things will clearly have equivalents if you're running this on a Mac or a Linux desktop. Go ahead and install the latest version. Go ahead and install all the main components. We'll also want to make sure it's added to the path so we can easily refer to it. Great, so Node has been successfully installed. Step 1 is complete. Step 2 is getting the Cloud Foundry CLI deployed. Now you can hit this at github.com/cloudfoundry/CLI/releases, and this will show you all the different versions that you can deploy and run on your particular machine. And this CLI is built in Go. Everything gets installed for you as you install, so you don't have to install any prereqs or worry about anything. I'm going to go ahead and pick the Windows 64-bit installer and run that. And that was very quick as well. And we can prove that installed okay by quickly going to a command line, and it should have installed it in the path. And just typing the CF command, which is what the Cloud Foundry uses, /v, gives me which version of CF is installed. You can see it's in my path. I didn't have to navigate anywhere else. So we'll be using that throughout the course. Next, jump to run.pivotal.io. Pivotal is the company that was spun off from VMware a couple of years back, and they have a commercial version of Cloud Foundry. They're the stewards of the public Cloud Foundry project. And so they also run Pivotal Web Services, where you can run this for free or for pay online. You get a free trial, no credit card, very easy sign up. There's other hosts as well that we'll talk about in a few minutes. But this is the easiest way for us to test out some of the key features of Cloud Foundry with no friction and simple no pricing or no cost. So we'll go ahead and sign up for free. I'll do this along with you. We'll provide an email address. The sign up is pretty straightforward. And I should be getting an email to my other account to get me signed up. I got that in my email, so I'll go ahead and paste that here. Great, now you just need to simply pick a password. I love them, but I don't necessarily want to hear about what's going on. Keep you out of your newsletters. Of course, I agree to everything you've asked me. And let's go ahead and sign up, and this should complete the process. And I get a couple gigs of space. I can do some fun stuff here. The final step is it does want to verify my account and who am I. So I'm going to type in a phone number here for it to go ahead and send a verification code to. Once you get that verification code, you can go ahead and just type that in and verify your account. Once you've got that, you're asked to create an org. So this is a concept we'll talk about in a few minutes. You can see what the trial gives you. It gives you a certain amount of memory, get to try some free marketplace services, which we will actually take advantage of. The price for a paid account is really pretty darn cheap, so something that you still may want to stay in full time. But we'll set up an org right now. You can name it after yourself. You can name it something that's going to be easy for you to remember. I'll call mine Seroder Pluralsight and start my free trial. So once I'm in there, it asks you if you want to install anything. We don't have to worry about anything too much here, since we've already got our stuff installed. And we can go ahead now and switch and deploy our application. Let's go ahead and switch to the directory that already has our project in it. We'll switch right to the Hello World directory. Now, to log into the Cloud Foundry, into the Pivotal environment, and regardless of which Cloud Foundry environment you're dealing with, because they all support the same API because it's all Cloud Foundry, you can use the same tool to point to Pivotal, to point to a number of other locations we'll talk about. So you can just type in CF login, and that will start you down the process. And here you'll just type in api.run.pivotal.io. You'll type in the email address you signed up for an account with. Then you'll type whatever password you provided. It authenticates you. You see you have a space all ready to go. You can see your endpoint, your user. All that information is already shown here for you. So what we want to do before we push, though, is because each name does need to be unique of your application. There's a very good chance that someone else has already taken this course ahead of you. Open the manifest.yml file, the YAML file, that you'll see is in the Hello World project. This manifest tells the application how to deploy. You'll see that right there, manifest.yml. And here you can give it a name. And so this name needs to be globally unique because we're putting this in a shared environment. So let's call this, for myself, PS Seroder /Hello World, just something that has a pretty darn good chance of being unique. Save that and close that. Now from here, all I need to do is CF push, and Cloud Foundry will read that manifest. You'll see it's doing a number of things. It uploads the components. It recognized that it was a Node.js application, goes ahead and uploads that. We'll talk about that whole processing pipeline in a few minutes as we walk through really the process of deploying Cloud Foundry applications. It goes ahead and deploys it, or starts it, gets it up and running, and we'll be able to hit this in just a moment. Again, going from code to running on the public internet in a matter of seconds is a pretty cool, powerful thing. Now we're already up and running, so if I hit this URL, I should see my application that's simply the basic Express Node.js application. And sure enough, I have my application here on the public internet, psseroderhelloworld.cfapps.io, the shared domain, and here's the basic Express app that we just pushed. This is clearly my unique one. Hopefully you would have the same one up there. But what we showed here was really simply taking the demo files, installing Node.js, installing the Cloud Foundry CLI tool so we could run this from the command line, creating a quick Pivotal Web Services account for free, and then just running a quick push command. And immediately, in a matter of 10-15 seconds, having our application ready to go on the public internet. So we just were able to run through a quick demo, hopefully whet your appetite for what Cloud Foundry is, how quick and easy it is to get started and push applications. Now let's talk a little bit about designing for PaaS, and specifically 12-factor apps, and what does that mean? So if you go to 12factor.net, this was something that the Heroku team initially put together as a leading and original sort of PaaS provider, and it really is meant to describe what are the sort of application characteristics, architectural considerations, that make an application really run really well on a PaaS. And so clearly some of these are made to, Heroku looks great in some of these, but there's a lot of great guidance here that works across almost any environment. It doesn't even matter if you were pushing this to a PaaS or building internal applications that you're going to put on bare metal or a virtual machine. These are really just good next-gen application design patterns. So let's walk through each 12. So the first one, code is version controlled. That's hopefully not too shocking to you, but it's one of those things where you're always tracking it in a version control system, that all the code matters, that you need to track it that way. And there's a one-to-one relationship between the code base and the app. So if I've got multiple code bases, it's not really an application, it's a system. It's something where I've got multiple pieces that are all coming together to form a system. And each component in these distributed systems is really considered an app. And so Each one of those apps can be 12-factor, but together they may form a system. But the one-to-one relationship between a particular code base and the application itself. There's going to be many deploys of a given app. And so what this means is that there may be only one code base per app, but there's going to be a lot of deploys, and the deploy is considered a running instance of the app. This could be a production site, a test site, a staging site, local development. Really, and that's the key, is every developer is still going to have a copy of this app running in their own machine, running on a Vagrant box, whatever they're doing, and each one of those qualifies as a deploy. So you just recognize that that app is deployed in multiple places. But the key is the code base is going to be the same across the deploys. So a developer might have some commits that they're working on locally, and staging may have some of these commits you actually haven't pushed to production yet, or things are still sitting in QA. But the key is they all share the same code base, and so they're all identifiable as different deploys of this same app. They may be slightly different versions, but the same fundamental code base is the same across all the different deploys. The next one is dependencies are declared and isolated. So what this is really meant to mean is never assume system-wide packages. Now sometimes you can install components and a packaging system that installs them system-wide. This could be in the .NET world putting something in the global assembly cache, or in Node you can install global packages. Almost every framework has some sort of model of installing things that every app could use. And so it's not scoped to a specific directory, it's scoped to everything. Now you can also deploy components that are scoped to a specific application, to that app. Really the key is, and the principle here is, you shouldn't assume anything exists in the target environment. These could be databases, these could be tools, these could be libraries. Really you never want to assume something's there. Instead you really want to declare your dependencies in some sort of manifest that calls out exactly what you need, what versions of those, and call out very specifically so that it's portable. So I can pick up my application, I can install it in a fresh environment that may not have already been prepped with a bunch of other shared libraries, or might not have the command line tools that I typically use to manage this. The key is to declare those very specifically in some place that can be interpreted at runtime, and all the specific dependencies can get installed. It's important to have some isolation so that dependencies don't quote-unquote leak from the system. The idea here is that when I'm declaring these, I don't have to worry about other people or other versions conflicting with others, and so I'm isolating this within my application container, because sometimes you do have different versions of libraries, you have different dependencies that different apps potentially in the same environment are using, and you do want to make sure you've isolated these so that these dependencies don't step on each other, or someone doesn't install an update that now breaks your app. That's something that does not work well on a distributed system, especially a multi-tenant one that may be sharing the same physical environment. One of the great things is this helps new developers, this helps product managers, this helps other people trying to get started with an application, because now the setup is easier. I can simply check out all the source code, I can check out a manifest, I can do my runtime update of packages, whatever the command would be for the particular language, and that's all I need, because the dependency manager can go ahead and install all the prereqs it needs based on some manifest, and I can get started right away. I don't have a 9-page installation script that I have to walk through of every step, or confirm this or confirm that. The next big principle is that configuration is stored in the environment. So code that's going to talk to your database, for example, may always be the same, right? The code itself, the query, the statement you may be making against a SQL store or against the JSON database, that query may stay the same, your code's the same, but the connection string is going to be different in each environment. Some of those properties may be different. If I'm hitting a software as a service application, the URL may be different between my staging and my production. So in each environment, characteristics of the connection are going to be unique, and those configurations should be extracted from the environment, ideally in environment variables. So these are easy to change between deployments. You can often include them in the manifest itself so that each one can have, here's the test connection string, here's the production one, and so forth. With a configuration file, I sometimes accidentally check things in when I don't want to. I might have security issues with some of that. So when I have environment variables, those are natural characteristics of the environment versus another thing I have to maintain or check in or track. These are something that can travel along with the environment, and they're characteristics of everything in there. These really should not be custom constants in code. So when you're writing a code constant and it's the fixed immutable constant that has a connection string, you're asking for trouble, right? Because that connection string is going to be different in each environment. And I don't want to have to maintain or do a code push different just because I want to change a connection string or I want to change a URL or what have you. I should be extracting all that information out. And I think most of us have been doing this for years, but even treating them more as environment variables are somewhat different. And I mentioned before, potentially not even configuration files, because if I can factor them out of the code and even out of the configuration file, I want to make sure I'm not even compromising credentials, or I've got other places where this stuff is now sitting that when I accidentally check it into source control, now somebody sees my cloud credentials or my database credentials because they're in a file now that's source controlled versus an environment variable that gets set at deploy time. That's not something that has to be statically stored. Sometimes you end up grouping some of these characteristics and, hey, here's all the test connection strings, here's all the QA, here's whatever, but that starts to really grow at times. So the idea is, ideally these environment variables are relatively granular, they're independent of each other one, and I don't have to have each of these variations. I'm not trying to group them. Instead, I'm really managing them for each deploy. Here's the database connection string for QA, and that's part of that push. I don't have one giant set of environment variables that have each individual environment listed. I try to make it easier to scale this. As I have more deploys, more environments, I'm not trying to maintain this ever-growing list of groupings of these settings. Instead, the settings are the settings, and their values may differ between environments. This is a big one. The idea of backing services as attached resources. So the principle here is that services are consumed over the network. I really don't treat a remote system any different than a local one. I've got all sorts of services that an application consumes. These are caches, these are data stores, these are queuing systems, these are mail servers, these are mobile backend as a service. There's all sorts of services that make up the application. And so the key is you're treating these as attached resources versus embedded ones. How do you treat these? And the goal is you're treating no distinction between a local service and a third-party service. It doesn't matter if I'm running MySQL locally or I'm running it in Amazon RDS. It should be exactly the same in my code. It should be ideally the same in my deploy. The only thing is different is my configuration or environment variable may be a little different. But I'm treating those services as attached resources from wherever. And so I'm coding that way, I'm thinking that way, instead of thinking of these as embedded. What this does is it keeps some of those dependencies decoupled. So I can swap these things out. I can replace one with the other, and it doesn't change anything, instead of having any tight coupling and expecting this to be on this particular server that's right next to my application. And that's the goal, is hopefully I can attach and detach at will. There may be a chance I am using a MySQL locally and I'm using a hosted one elsewhere. We'll talk about that. May not be a great idea in a few moments. But I do potentially swap things out. I may use a different provider. As long as I'm going over the same sort of interface or it matches the same interface, that shouldn't matter. So again, treating any of the backing services, anything outside of your code as an attached resource, is a great principle. The next one is that build and run stages are separated. So what we'll talk about here is that you can't change code at runtime, right? The whole point should be everything flows in one direction as we have code, because those changes in production, really there's no way to propagate those back to the build stage. I log into production and I change a configuration value, or I change the code in production because, hey, there was a bug. All of a sudden now I've broken everything because it doesn't flow back properly. I've broken my rolling deployment process. I want my releases to have IDs. Right? I want to make sure that every release has a unique ID. Either this could be a timestamp or an arbitrary incrementing number, whatever it's going to be. But the key is it's a ledger. It's a way that I'm deploying my releases. Once it's released, I don't change it, right? It's immutable. The only thing I can do next is create a new release. And so continuing to move forward with this versus having sort of fungible releases that I log in, I make changes, and I've lost control of it. The key is it should be very repeatable, very standardized. A build can be complex depending on what it is. So the build stage may be more complex than production because a developer may be throwing certain flags on. There may be errors during some of the deployment because they're working on creating that manifest, or they're defining what the build may look like, and devs are initiating this, right? Developers may be doing builds 10 times a day, 10 times an hour, and so those builds may be complex as they're assembling those and putting those together. This differs from runtime because runtime should actually be automatic. Running this, doing the production deployments and having this in production in the case of, let's say, a node goes down and another one has to be spawned back up again, that should be automatic because that may happen at 2 a.m. on a Sunday, on Black Friday here in the US when everyone's shopping like crazy. I don't want to have to page my developer because that's happened. Runtime maintenance and deploys of recovering from crashes should be automatic so that that sort of stuff is just baked into the framework of what I'm building versus having to have these sophisticated run books for a runtime level update. The next principle is that applications are executed as stateless processes. So this is something that is, I think, trickier for some developers who've been traditionally building these sort of 2-tier, 3-tier apps on premises, and you think about in-memory state, you think about session, you think about things that are even being stored on the file system on an individual server, you're not thinking about this sort of constantly replaceable, scalable model. The key is you share nothing. This should be the goal, right? That you're not sharing anything between the various nodes, and that any data you need to persist is stored in some sort of stateful backing store. This may be, again, session information. This may be progress as I'm walking through a purchase wizard on a website and I'm buying something and walking through 3 steps. Whatever that may be, anything that's supposed to persist should be in a backing store. And you should be able to assume that these processes are going away at any point. So if I'm using local memory in my instance, or I'm using the file system, that's got to be a cache only, a single transaction sort of cache. So I'm maybe pulling a file, or I'm doing a job, and if something happened and that machine went away, I could continue some way else. But the key is that the 12-factor app, it doesn't assume anything that's going to be in a cache or on the file system will be available later. Just assume that is purely a buffer, and I'm allowed to lose that in case I destroy the process, start a brand new one, or whatever. That's the key, because that is going to happen in a PaaS environment. And if you're dependent on the file system, you're dependent on something in memory, you're in trouble, because you're simply going to lose that on occasion. And so you do things like avoid sticky sessions. So when I'm not dealing with a web application environment where my customer is continuing to get pinned to an individual server they started with, and now all of a sudden all their shopping cart or their purchase history or whatever is pinned to that machine or that instance. So if that instance goes down, that customer is completely hosed, right? They have all of that data been lost. They've lost their session. They're probably going and doing something else, and they're frustrated. So you want to avoid a sort of sticky session where one node is doing all of the work for a particular request. Instead, you should be persisting any data in a backing store. This one's a little more esoteric, but the idea that services are exported via port binding. So the principle here is that apps in the 12-factor model are completely self-contained. It doesn't rely on any sort of runtime availability of a web server or a database or this or that. It actually may export HTTP as a service, so it may include its own embedded web server. And you do see this a little bit more now, right? You see that Python ships with a basic web app, Ruby ships with one, Java has one. So you've got some of these where you can almost take a native empty environment, push an application and start it up, and already have a web server kind of baked in, or a lightweight database or things like that. Again, the point of some of this is that you're trying to make things very, very self-contained so that I can push things to new environments. I don't have complicated setups or dependencies or expectations. I may be listening on a specific port. This could be HTTP, right? Typically, you may think of this as a web server where I'm listening on 80 or 443, but this could be all sorts of things. This could be a Redis cache. This could be some sort of other queuing thing where you're listening on a specific port for this app server you've embedded in your app. This is relatively specific and idealistic. This probably works better in some environments than others. But again, it's the principle you're thinking about. You're thinking about, how do I reduce my number of dependencies on the host environment so that I can push quickly, I can recover from failure quickly without expecting a lot of things to be there. I want to make sure I can deploy without that so that I can get things done quickly and efficiently. We talked about stateless processes a few moments ago, and this is really where this starts to come into play, and that applications are scaled out via the process model. They're first-class citizens. When you're running your code, there's going to be a lot of little processes that might run a specific thing. You may have processes that run a specific job. You've got others that might do API levels. You have some that are doing database work. All sorts of things going on. All these processes get treated as first-class citizens that can scale and so forth. And work may be assigned to a process type. I may have a specific type of work that's handled by this process. Hey, I'm sending out email messages. Hey, these are HTTP requests coming in. These are worker nodes who pull stuff from a queue and update a database. Each sort of work that the app has to do may be assigned to a type of a process that's going to do that work for you. You may have processes that span servers, so an individual process can also do its own kind of threading and spread things out within a particular instance. But the idea is that you also have some tools and you've got technologies where that process may be spanning across machines because you're growing so much that you can only vertically scale so much, right? I can only add so much CPU and memory and storage to an individual machine that I don't want to be able to scale out. So a process may span machines. They also point out the idea is that you want to use OS process managers. You want to make sure that you're not necessarily writing your own processes that are trying to check things and recover on things, wherever possible, you're trying to use the tools that the OS provides to detect failures of a service and restart it automatically. Again, making it simpler to handle these sort of operations versus writing your own things or trying to detect and recover. Use the OS. So again, it's one less thing you have to ship and worry about. Processes are disposable. Really, when you think about this model, we've talked about the scale out, we've talked about stateless, but the point is you're trying to minimize startup time. You're trying to make it simpler so that I can stop and start a process at any time. The process should start up in a few seconds, right? It should have a 10-minute boot process where it goes ahead and does a bunch of things. They should be able to be started pretty quickly, because if a process crashes and I want to come right back online, that's got to be quick. I have to make sure that I can quickly be handling traffic and not waiting to do some things. So it's important to build these processes that are relatively lightweight. I want that minimal start time and also the graceful shutdown. So when it does shut down, when I tell a process to fail or it actually just crashes itself, I can all of a sudden stop listening for calls, right? I'm not taking any more web traffic and I can route traffic elsewhere. If I'm a worker node, I release the work I was working on so someone else can pull it. I can somehow gracefully exit without simply leaving myself in an inconsistent state. Worker processes, I mean, it's great when these things are stateless. And again, I might have a whole number of nodes pulling work from a queue. The key is going to be, am I releasing that? Or now have I left this order stuck in purgatory because no other worker node can pull it because this one has a lock on it that it never released. So you always have to think about what happens when this thing fails. Not if it does, when it does. So that you've built a process that can gracefully shut down. And even if it doesn't gracefully, there's another process that can potentially release locks or things like that. You want to be robust against that sudden death because sometimes it won't be graceful, right? You're hoping that you're robust against crashing. You will crash at some point, but if it does, you want to make sure that you can start back up cleanly. You don't want to have any mandatory cleanup tasks that happen because sometimes they may not happen. And so if you're expecting those to happen and there's a catastrophic failure and now again you're stuck with an inconsistent state, that's no good. So you do want to make sure, again, you've thought about how this process works. Parity between application environments is a big part of this. So you do want to make sure as you think about the gaps, there's time gaps, personnel gaps, tool gaps. What this means is you've got time gap where a developer can be working on code for a while, right? They may not be checking in every minute. They may be working on code in general that spans days, weeks, even months before it hits production. You've got people gaps, right? You've got devs who build stuff. You've got ops potentially who deploys it. You have those that are there, at least in a lot of organizations, and you have tool gaps where developers may be using lightweight things locally, like they're working on a Mac environment. They're using Nginx instead of Apache in production. They're using a lightweight SQL because they don't want to deploy a full-on MySQL or Postgres environment. And all of a sudden they push to production and the tools are different, right? Those gaps are there all the time. We do see them, I'm sure, in most of our daily life. The goal is, though, you want to design for continuous deployment by keeping those gaps between development and prod small or non-existent. And that's the idea, is how do I make that time gap small? Right? How do I make sure that a developer can write code and push that quickly and easily and not have days or weeks or months between commits and pushes to production? How do I make that personnel gap small by making sure that a developer who writes code isn't stepping away when it comes time to push? They may be closely involved in it, maybe even watching it and monitoring it as it goes to production. And with the tools gap, how do I make sure development and production are as similar, if not as identical as possible? This is super important for backing services. It's really easy sometimes as a developer to say, let me use a lightweight clone of something that we have in production because I don't want to build on a full-on production environment on my workstation. So again, I'm going to use a lightweight SQLite in Postgres in production. I'm going to use a cache in memory right now, and I'm going to switch to memcached in production. I'm going to take some of these compromises because I want to be a little simpler. But nowadays, it's so much easier to be able to run some of these things in production. So configuration management, the use of containers, things like Vagrant, make it a lot easier to say, look, I want to actually run Chef and Puppet in my local environment. I want to run the full RabbitMQ on my machine. I can do all of those things now much, much easier, and it's worth that investment. Because when I take away these gaps, when I make sure my tools are the same in each environment, and my people are involved, and my time is short, I'm making it a lot easier to push and maintain robust applications that don't have fundamental flaws. We talk about logs treated as event streams. Really, as we think about logs are streams of time-ordered events, meaning I'm collecting them from all the different processes running throughout my system, all the services running within my distributed system. And these things are sometimes text files, right? We just have a a running list of things going on. They might be exceptions, they may be information statements, and so forth. They don't really have a beginning and end, they just keep going, and you're just treating them as a stream of events. The key is the app shouldn't be too concerned with storing its logs or routing them or what have you. It shouldn't be trying to do anything sophisticated here. Using a logging framework to simply write its event stream unbuffered, and however it gets processed, whether it's processed by logs or it's processed by whatever, that's not the concern of the app. The app is simply writing out the events that are going to be part of this log stream. It's the execution environment's job to capture and store these. And so its job is to collect all of them and potentially make sense of them, or simply capture them all and put them into a particular location. Different log files, could be writing it externally, and that could be, again, routed to a file. It could be sent to an external service. I'm throwing it in Splunk. I'm doing whatever. It's the application execution environments to do that. The application shouldn't be concerned with it. When we talk about management tasks run as one-off processes. So instead of using your local command line and running a database script against the database and making a change, none of that. Instead, you always run in the identical environment. You run management tasks in the environment they're in, so you don't have weird side effects from things that are on your machine or different, or you're running it from a jump box or things like that. The goal is you're trying to ship admin code with the application code. You're trying to make sure that these administrative tasks are treated as processes within the environment. If I'm running scripts, those things can be source controlled. I can make sure that I'm not just running arbitrary things. I'm actually not just doing an update arbitrarily from a command line or a terminal window. I'm actually able to script this, potentially make it part of my configuration management process, and able to do that in a consistent way. So again, I don't want to run from the local terminal. I don't want to run directly against the database. I'm going to want to do it from within the environment, so I'm getting all of the benefit and potentially the harm. If there's anything wrong in the environment, I'm not masking it by doing it in an environment that's not the same.